Be explaining how to solve coin combinations 2 from the CSES problem set. The question goes as follows. Consider a money system of n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ordered ways you can produce a money sum x using the available coins, right? And then they basically just explain the inputs and like give an example. And so here, let me make it lighter. So one of the, I guess with these problems where they want you to explain like distinct what does it say? So distinct ordered ways, right? So like basically these are in form of how many times you can, how many ways you can have X number of coin 1, number of coin 2, and so on to have the sum x, right? And so, well, yeah, right, rather than coin 1, coin 2, coin 1, and then this giving sum x, right? And it's basically easier to explain with code, so I'll just do that right here. I'll code it out, and I'll explain it after I code it out. So here, those are the inputs, or actually no, one more. Right? And all right, so what do we want? So we want to have it's a DP problem, so we want to have a DP array with I'll make it this long array with what, n or x plus 1 values, and I'll just set this all equal to 0, and then dp0 is 1, right? And to this part, it's a lot like the other videos, right? Other DP problems we have done. It's basically the same thing. And then now we're gonna loop through so okay, so now this is where the different part comes in, right? This is where the difference is. So if it was the other problems, you would be looping through the x, right? And then looping through the coins, and then basically doing the DP process, right? So the transition, right? But in this question, this particular question, and many other questions that's like this, we want to loop over each coin first, right? And then each x, so x j plus plus, and basically the same transitioning process. If j minus ri is greater than or equal to 0, then dpj plus equals dp of j minus ri, right? And then we want to mod it, and then finally output the answer. So here, now the explanation comes in. So why do we do this, right? And so we have to go back to the statement I said earlier, which is in this problem we try to figure out how many ways you can have the number of coin 1, number of coin 2, blah blah blah, to have some x, right? So like in this part, coin 2, so 2 is coin 1, 3 is coin 2, and then 5 is coin 3, right? And we want to have so here, let's go back to this example. So one of the solutions to this problem is this 2 plus 2 plus 5. So what's 2 plus 2 plus 5? So 2 plus 2 plus 5 is 2 coin 1, two number of coin 1s, and then 1 coin 3, right? And then another way, and then wait, hold on, and then 0.2. And the next one, it would be 0.1, and then 3.2, and then 0.3, right? And then so on. So here, I'll do the other one too. So 3.1, and then 1.2, and 0.3, right? Okay, so here, so this is how we want the solution to be, right? This is how we want the solution, each solution to be. And then to count each distinct I guess mini solutions, we want to start with the coins first, so that instead of referring back to the coin, much like how we would do if it was if we were looping like this, we would be referring back to the coin multiple times, right? So we would be like so coin 1 may have existed in order to make, I don't know, I minus j, right? And then we'll refer back to it now, and it just gets complicated, right, for this type of question. So we just want to make it so that we only go through the coins once, and just count how many ways we can do it. I don't know if that made sense, but I suggest you go to again, I'll be using all right, again, going over to guide, right? Introduction to DP, and I'm pretty sure, what's happening? Well, okay, so introduction to DP, scroll down. Okay, so actually it's not introduction to DP, I'm sorry. It's like loading really slow today, but I'm pretty sure it's called knapsack, or I guess the module. And knapsack is a common DP thing where we want like the maximum weight in a limited knapsack. So this and then this problem is also an example of that, right? All right, so knapsack. Okay, knapsack, and then yeah, here I've done this problem, right? Coin combinations too. Go over to solution, internal solution, and then it has a really clear guide on how to actually do this. And then see, coins ordered differently. So it just makes our life easier in this type of question to just loop over the coins first, and then loop over the x value, right? And now we'll just test the code out. Here we go. Whoops. 3. I did that right. That's good. Submit the question. Ooh, the file is okay. Okay, we got this right. So, all right. That's basically how you solve this. Bye.